Good morning, everyone, or good afternoon. Thanks so much for joining today's webinar on Mobility COE. My name is Joshua Ma. I am the Director of the Center of Excellence on New Mobility and Automated Vehicles, also known as the Mobility COE. If it's your first time joining us, the webinar series, or the first time you're hearing about Mobility COE, please let me know. Please let me provide a quick introduction. In October 2023, the Federal Highway Administration entered into a cooperative agreement with UCLA and our partners at CMU, NRail, SUMC, University of Alabama, and Metro Lab to establish a mobility center of excellence as defined in the bipartisan infrastructure law. So the purpose of our Mobility COE is to collect, conduct, and fund research on the impact of new mobility and high automated vehicles deployed at scale. So our focus areas include land use, urban design, transportation systems, real estate, equity, municipal budgets. So it's a very broad focus. And for more information, please visit our website at mobilitycoe.org. Today marks the fourth webinar of the Mobility COE webinar series. These webinars occur around bi-monthly, each focusing on specific topics of selection. In many cases, it's the topics that are of a lot of interest to our stakeholders, like cities and states. So information about each webinar and potential future workshops will be announced on our website, LinkedIn page, and distributed via our mailing list. So please subscribe via website and follow our LinkedIn page for future updates. Now, before we start, a few quick housekeeping notes. First of all, the webinar is being recorded. It will be posted on the Mobility COE website. Second, all participants, except the speakers, will stay muted for the duration of the webinar, in this case, about first 1 hour. And then after that, we will open the floor so the participants, the attendees can actually unmute and ask questions, interact directly with our panelists. Third, we understand there might be questions coming up during the webinar, during the discussion between the panelists. So please put any question in the chat box. And me as a moderator, I'll do my best to monitor them. If I see something that's very relevant, I'll ask those questions directly. And for sure, we'll answer those questions in the chat box during our Q&A session in the last 20 to 30 minutes. So that's all about housekeeping. Today, our topic is very unique. This is a topic that is one of my favorite topics in the past couple of years, is when ADS meet the rules of the road. As you know, that automated driving systems, right, it has now reaching the point of deployment at scale into our roadway transportation networks. We've seen Waymo has increasingly deployed at more locations, more cities. And then during this stage, right, we see that it also potentially faces a lot of operational challenges. One of them being adhering to traffic rules and regulations. In particular, in the US, these rules and regulations are even going to vary from jurisdictions to jurisdictions. Also, in the rules and regulations, sometimes it's hard to understand even for human beings. Sometimes has a very vague languages. I guess it's also difficult for both machine and human to understand. So it's by itself is a very complicated issue to myself. So this is the topic that I've been discussing a lot with our government partners, industry partners, and also my students within the team all the time. So this webinar, will aim to kind of address some of these questions. I don't think we will have a solution at all, when we walk out of this virtual webinar today. But at least I hope we can, just discuss these issues, understand the different perspectives, different approaches out there, and also get some consensus on for example, what is current ADS capability of compliance? Right? What is the different stakeholders should get involved and questions like that. All right, so I just want to give you a quick overview of the question today, but this is very high level. Probably you have read them elsewhere as well. I will leave more in-depth introduction to our panelists. Before that, I want to do a quick introduction of our panelists. So panelists, please, I will quickly say your name, your title, your organization, and I would appreciate if you can just unmute yourself and say hello to the audience and provide any introduction or background information that you would like to share with the audience. Now, this is not the 3 to 5 minutes. This is a quick opening remark. So, all right. Our first panelist is Dr. Siddhartha Kastegar. He is head of safe autonomy at WMG, University of Warwick, UK. Siddhartha has been very contributing a lot to the scenario testing, and that field has been because of his work has been developed a lot. Siddhartha, great to have you here.
Thank you so much, Jashi. Thank you. Firstly, thank you for the invitation. It's an absolute honor and a pleasure to be here. And thank you for choosing a very interesting topic. And I think a topic that over the years has slowly got interesting conversations happening. I think one thing I would like to highlight here as an opening comment is I think I would suggest to you not to set the bar so low. I hope we get to some solutions as a result of this webinar. So I think the conversations and the set of panelists that you've chosen for this webinar is absolutely brilliant. So I'm looking forward to this conversation. The big question I would pose to as my opening comment over here would be compliance to traffic rules is an absolute essential aspect of the safety assurance, more so from providing predictability to other road users who are actually sharing the road with the automated vehicles. So a lot of people tend to think that compliance is more for safety of the automated vehicle. It's actually to ensure the safety of the wider road ecosystem, because others will be expecting, and there needs to be a level of predictability from the automated vehicle towards others. So I'll stop there as my opening comment.
Yeah, great. Thank you, Siddhartha. Our second panelist is Roxanne Mukai. Roxanne is the operations engineer of Maryland Transportation Authority. Roxanne also, I know, hold a couple of important positions over the years, the National Committee of Traffic Control Devices. So that's, Roxanne, great to have you here. You're so important today.
Good morning, I think, for the California folks. I'm on the East Coast, so it's actually good afternoon for all of us. And I suppose for Siddhartha, it's good evening. But thank you, Joshi, for a really, really interesting topic. I look forward to the conversation, and I don't think you're setting the bar low. I think it's just a really, really complicated topic that will take a lot of work for us to get to a good conclusion. And when I say good, I mean safe, operational, functional, livable for all of the different entities that are involved. And I'll save the rest of my comments for the 3 to 5 minutes.
Great. Thank you, Roxanne. Our third panelist is Sagar Beher. Sagar is the VP of Customer Success and Safety at Fortelix. Sagar's been in the AV industry for so many years. Great to have you here, Sagar.
Thank you. And since everyone's commenting on the bar, I'd say my take on this is you've under-promised. Now it's up to us panelists to over-deliver. So I look forward to doing that. I will also point out to all the audience that I have chosen to talk here as an individual expert. I am the Vice President of Safety and Customer Success at Fortelix, and have been involved in developing these systems at a bunch of Silicon Valley companies and automotive OEMs in North America and Europe. But nothing that I say here is reflecting the official positions of current and past employers. And that way I can speak more freely and make the discussion a tiny bit more interesting. Thank you.
Thank you, Sagar. And thank you for the disclaimer. Our fourth speaker is Kelly Smith. Kelly's a lead systems engineer at Kodiak Robotics. Kelly is our ADS developer today. So Kelly, thank you for having you here.
Yeah, it's a pleasure to be here. Yes, I've been with Kodiak Robotics for a little over a year and a half. I've been in the AV industry altogether for about 4 years. And prior to that, I worked in the aerospace industry for 13 years doing onboard autonomous spacecraft systems. I'm really excited to be joined with these esteemed panelists today, and I'm looking forward to the conversation. I would also like to echo Sagar's disclaimer about opinions are my own, not reflective of my employer, in order to facilitate a more candid discussion. Thank you.
So Siddhartha, you see that how academia can freely talk about whatever they want. Okay. All right. Thanks so much for all you've been here. I really appreciate. So I tell my colleagues it took me quite a while to put all this panel together, and it's so difficult to have this one slot. Thank you so much for agreeing to be flexible to be here at this time. Okay. Now, without further ado, let's get started. I kind of have divided this webinar for a couple of parts, but we'll go through one by one. And as I said, we will have discussions in the beginning, but then we'll leave questions, Q&A at the end. If you have questions, put in the chat box. I will try my best to monitor and help you ask the panelists. So before we deep into individual questions, I prepared for the panelists. Now, I've kind of requested all panels to give us a 3 to 5 minutes general introduction. Some of you, I know you prepared slides. I appreciate it. So the purpose is to help the audience, in my words, understand how complex this issue is. Some of the questions I hope the panelists will talk about is, what do traffic rules even mean to ADS systems, right? Or from your background, as IO, as ADS developer industry, or as verification and validation engineer. So what do you mean, right? What does it mean when you have to consider traffic rules in automated driving systems development and operations? And I know we also know there's a lot of stakeholders out of it. It's not just ADS developers that are involved in this, right? Because vehicles operate on the roadway, there are infrastructure owners. There are many others, right? For example, law enforcement, right? They are going to determine if most likely I comply with the traffic laws or not. So I will stop here. But I will give the panelists each about 3 to 5 minutes to give introduction. This will lay the foundation for our discussion today. Okay, so volunteer, who want to start first? Okay, cool. Thank you, Kelly.
All right, thank you. So at Kodiak, we develop level 4 autonomous trucks, primarily focused on 3 main verticals. So over-the-road trucking, industrial applications, typically on private roads, and then defense applications as well. So at Kodiak, I lead efforts associated with quantifying our risk of collision using a tool called probabilistic risk assessment. As well, additionally, I lead our driverless safety case efforts at the company. Prior to joining Kodiak, I led safety case efforts at Embark Trucks. And prior to that, like I said before, I did a lot of safety critical flight software at NASA. What we're looking to do in any discussion of traffic laws and regulations is to discuss really the OD. Where do you intend to operate? And what do you owe the other actors of that system who also use that system? So we developed level 4 Class 8 trucks that primarily operate on US interstate highway system. We also do some small surface street driving at the beginning and at the end of the routes. Because these routes are relatively fixed to go from A to B and B to A and A to B and B to A back and forth, there's far less variability for some of our routes than what a robotaxi company or a general purpose passenger vehicle would be required to do. Instead, we follow a schedule and we deliver goods from back and forth and just kind of run that route or that shipping lane back and forth. That simplifies our problem. Not only does it simplify it because the interstate highway rules of the road are relatively consistent from state to state to state. There are differences in regulations for tolerable speed limits for trucks and things like that, and what the expectations are for lane selection for heavy trucks. But generally, it's pretty consistent, which makes our lives a lot easier than our friends who have to develop autonomous vehicles to operate in dense urban environments where there may be more local idiosyncrasies. So the traffic rules are really attempts to codify and come up with expectations for driver behavior that are punishable with force of law. However, in addition to those formal rules, there are many unwritten rules as well. So like safe and reasonable following distances. What constitutes a safe lane change? How much following distance should you afford to someone who's trailing behind you in your destination lane? These sorts of judgments are not just technical probabilistic risk assessment based judgments. But there's also cultural values here as well. Where I grew up in a very rural area, what was considered a reasonable following distance is very different from where I live now in Houston, Texas, where people will be very, very close. And I think it's still pretty nuts because as a kid, I grew up driving on icy roads. And so you have to give very heavy following distances for those sorts of situations. But culturally, it may reflect different values and expectations about what each driver owes each other. So it's really a function of the ODD. And thankfully at Kodiak, because we operate so predominantly on interstate driving, that keeps it relatively consistent for us. And the variations are actually quite easy, typically, to manage in terms of speed restrictions, expectations of what's our emergency response for other vehicles and things like that. Where it gets really tricky, and I think where a lot of the discussion today will center, is the unwritten expectations that sometimes come into conflict with one another. And so we may seek to grant some, maybe a road user some sort of consideration to do a lane change away from something, but that might induce us to have an unsafe following distance or an unreasonable following distance. So how do we weigh the conflicting objectives here, given the essentially infinite permutations of this space? So that's really what I think is like the crux of the issue, is how are we showing that what we are choosing is a reasonable, defensible selection when you have two objectives that are in conflict for one another. So that's a little bit about me, about how I'm approaching this problem from an ADS developer perspective, and I'll turn it back over to you.
Thank you. Thanks so much, Kelly. I guess we'll eventually talk about different perspectives, how they kind of reconcile with each other. So maybe I can go with a cigar. I know you. I think there's a good transition between Kelly and yours. Yeah, go ahead.
Sure. Thank you. So I think adherence to traffic rules and traffic rules by themselves, it's a very fascinating topic for a variety of different reasons that make it fascinating. There is just the sheer diversity of the rules from one region to another. There is diversity in the stakeholders who care about those traffic rules. There are numerous interpretations of what following traffic rules actually means. And there are diversities in the purely technological methods used to enable an AV to adhere to a traffic rule, as well as the technological means to validate that an AV in question is going to adhere to traffic rules. So those are some of the reasons just why, no matter which angle you approach this topic from, it ends up being fascinating. Now, before we jump into solutions, I like to always start from philosophy. So my philosophy is, the starting point is we ask ourselves what traffic rules are for, why do they exist? And my belief is that we created traffic rules so that if a given vehicle follows those rules, in fact, if all vehicles in that traffic horizon follow traffic rules, then there is a higher probability of leading to a safe outcome. So traffic rules are a means to an end. That end is safety. It also has the secondary effect that if one party is in violation of a traffic rule and there is a consequent loss of safety, we are able to allocate responsibility in different ways to the participants. So the traffic rules are there in order to create safer outcomes. And those rules are written at a level of abstraction that acknowledges that there will be humans in the loop who will interpret those rules, understand what they mean, and apply them. So there may be a traffic rule, but I, as a driver, am human, and there is a certain expectation of me understanding the letter of the rule and the spirit of the rule and generally adhering to it. And we'll unpack what adhering to it means throughout this webinar. Similarly, when the rule is violated, there are humans in the loop, for example, law enforcement officers or judges who interpret what that rule was for, again, in word and spirit, and determine whether the correct objective has been met when they evaluate a case where violation of traffic rules have been involved. And so this concept of relying on the human who is in the loop, I believe it is a feature and not a bug, because it enables us to write rules at a certain level of abstraction. It enables us to encode a certain amount of ambiguity in how those rules are specified and evaluated. And this makes life pleasant for everyone. Our rules are not written in a rigorously logical manner that a machine can interpret. And I'm sure we're going to talk about that too. So what are we trying to do here? We are trying to introduce autonomous vehicles on the road and still preserve safety. And we are saying that because autonomous vehicles need to be safe and rules are a way to be safe, therefore, autonomous vehicles should follow the rules of the road. We are also saying that because autonomous vehicles share the road with other humans and humans follow the rules, therefore, autonomous vehicles should also follow the rules. And I think by and large, this is a good thing. This is a good expectation. They should follow the rules, and where necessary, the rules should be amended in order to continue preserving safety. So we'll also talk about where and why rules should be amended. I'll also close off by saying, how are we trying to make AVs follow those rules? And I think there's a few interesting approaches that the industry is following, which have a lot of benefit, but at the same time, I think some weaknesses. So what we're trying to do by and large is we take these human written rules and meant for consumption by human beings, and we are trying to codify them using the language of math and logic, make them very rigorous. And the intent is we take a rule, we codify it so that a machine can understand it, and then we have various ways to make the machine actually adhere to those rules and validate if the machine is following those rules. And when we inevitably run into ambiguity, we say, what do? Well, we disambiguate those rules. And so we are following a trend where sometimes to me, it feels like we are saying, we will take every human rule and we will disambiguate the heck out of it till it can be modeled using math and logic, and then a machine will follow it. And I think this is useful for a lot of cases. And there are some cases where I'm like, is that really the approach we should take? So it's something that I hope that we'll discuss today. By and large, I think it's a good approach and it will take us a long way there. And I am an engineer. If an approach is going to take me 80% of the way there, I'll take that and I'll figure out what to do with the remaining 20%. Like, just because a method can't solve all your problems doesn't mean it's an unworthy method. But we should also talk about whether there are other approaches. So, and we should talk about cases where rules are ambiguous, and whether you should have followed the rule or not depends on whether a bad outcome happened or not. Often the case is, if no bad outcome occurred, well, you are right for doing what you are doing. But if a bad outcome had occurred, then you shouldn't have done what you did. So what do you do with those situations? So I hope we'll have a rich discussion. I think I've left enough teasers here and primed up the remaining panelists to talk about these things. So I'll stop for now and we'll discuss more later. Thanks.
Great. Thank you, Sagar. I will just move to Siddhartha. It seems you're very much willing to say something. Do you want to go ahead and
So thank you, Jashi. And like always, I agreed with Sagar 80%, but 20% I disagree. And I'll start off on that point itself. So firstly, thank you for the very interesting background. And thank you, Kelly, for raising the ODD point. And thank you, Sagar, that we should not codify the heck out of the rule itself. But I'd like to take a step back from the conversation and try to understand what is it we're trying to achieve when you're trying to codify traffic rules, or how we call them in the UK as rules of the road. So firstly, I'll also put a disclaimer. In the UK, actually, we're quite privileged in a sense that we only have rules at the national level. So if I make an analogy to the US, it's actually federal level rules and not state level rules. So that makes our life easier to some extent. So at WMG at University of Warwick, we have gone through each of the 307 rules of the road that we have in the UK. We call them the highway code. So we've analyzed each of those 307 rules as a part of a project that we did for the Department for Transport. And, and what we found out was that even after analyzing each of those 307 rules, each of those rules is actually saying one of two things. It's either saying that you're doing some behavior somewhere, or it's saying that you're not doing some behavior somewhere. As simple as that. And I like to keep things very simple, taking a first principles approach. And each of those 307 rules boil down to these two types of statement. And when you try and put another hat on, like the ODD or scenario-based testing hat on, then you realize that somewhere is actually an ODD instantiation or an ODD attribute, and doing or not doing is actually a behavior or a behavior competency. So essentially, any rules of the road or any traffic rule is a combination of an ODD attribute and a behavior attribute. So what we did was we took this understanding and tried to apply this in our attempt to code the heck out of the rule to see if we could actually make it as a combination or a function of an ODD attribute and a behavior attribute. And to our surprise, we were able to do that. We were able to actually codify each and every rule with that. However, that's where comes in the point that Kelly raised, that when we did that, a lot of the rules were actually by design, as Sagar said, ambiguous and had what we call as a qualifier, like suitable distance, reasonable time, and so on and so forth. So while you could codify the entire traffic rule as a function of ODD and behavior attribute, you did end up with what we called as a qualifier, but essentially is the ambiguous term, which somehow you need to provide a number to or need to provide a justification for the number that you choose. So in our work, what we ended up doing is providing some sort of a guidance on how do you go about putting up the number. Now, the challenge we had in the UK, so we've got a type approval regime when it comes to safety assurance, contrasting with the American setup, which is more self-certification. But I think this is true for both. In our world, our regulators do not want to say it should be 3 seconds or it's only 3 meters is the suitable gap. So what we've come up with a position is that each and every rule as used by the developer should be unambiguous, should be verifiable. But the most important thing that we've said is should be explainable. So rather than the regulator or the state authority saying it should be 3 meters or 3 seconds or 10 meters or 10 seconds, it should be the developer who says what was the value that you chose and why did you choose it. And going back to Kelly's point, that value would be a function of the ODD or the target operational domain where you're going to deploy. So what might be suitable in one area will not be suitable in another area. So taking a European context to it, north of Italy drives very differently to south of Italy, while the rules of the road is the same for both all of Italy. So those are the kind of complications that we have to figure out. Having said that, being an engineer like Sagar, I still believe the codification does help in terms of, at least it gives me some level of structure to the traffic law or rules of the road itself. So what we've been able to do is come up with this codification process that we've then taken up to at a United Nations level, at the UNEC discussion level. So what we've demonstrated is it's not just a process that we could apply to the UK's traffic rules. We've demonstrated that any traffic rule, be it in Europe, be it in the Vienna Convention, be it in Canada, or any of the state traffic rules within the United States, each and every rule is a function of ODD attribute and behavior. And on top of that is this ambiguous term that you need to verify, and you need to disambiguate. So one of the things I wanted to close off by saying is the fact that there is a lot of work in this space happening, both within the states, but also internationally. And I think there is a need for some level of harmonization, and I'm very sure Shashi will come to that a bit later. Not in that saying that it should be 3 seconds everywhere. What the level of harmonization that I'm personally looking at is at least we can all get to defining the traffic rule, the format, the content structure in the same way. Because as I see it, each and every state in the US has a very different way of defining the traffic rule. Within the UK, we're lucky that we've got a single federal traffic rule, but each of those rules also have a different structure to it. So if we come up with a common structure, then you can also link it with scenario-based testing, because scenarios are also a function of ODD or can be mapped to ODDs. Rules of the road can be mapped to ODDs, and then you can actually map a scenario to the corresponding traffic rule that it should be compliant with. So that's where I would stop in terms of saying that there is some bits that can become harmonized and some bits that will require a case-by-case judgment by the developers. Thank you.
Yes, thank you, Siddhartha. Some of those questions we're definitely gonna come back and address those. I will, before we start those in-depth conversation, Roxanne, can you go ahead? And we have been talking. This opening remarks has been a little more technical than I expected. So if you can bring us back to kind of the overall big picture, the different stakeholders and your understanding from IO perspective, would be great. Thank you. Go ahead.
I think I followed instructions like a good government employee. Did I get the right slides showing?
Yeah, it's coming up. Yes.
Okay. So unlike our two friends from the private sector, I actually wrote out our disclaimer. So whatever I say today is my opinion, and it's not supposed to be attributed to my agency and or any of the entities that I'm associated with. But I am a civil engineer by training, and I have been working in the highway industry for a long time now, close enough to look at retirement and go, that's actually doable. But I work for an agency of the state, and we own, operate, and construct all the toll roads in our state. We have our own police force, so enforcement is an issue. In addition to serving as the agency's connected and automated vehicle liaison, I'm also chairing the Connected and Automated Vehicle Joint Task Force at the National Committee on Uniform Traffic Control Devices. And I'm serving as our state civilian liaison for our emergency responder subgroup on connected and automated vehicles. So traffic rules, Josh's question, this is really fun for me. And I wanted to go on and on and on, and I'm not sure. Josh, you might have to cut me off. So for me, the traffic regulations are intended to support the safe and cooperative use of our roadway system. They should provide some clear, uniform, and consistent directions where needed, such as establishing who gets to drive through an intersection first. For those regulations that we do write down, they have to be effective. And for voluntary compliance to occur, these regulations not only have to fulfill a need so people want to obey them, they have to be enforceable. And that includes on the automated vehicle, which, yes, for most states, we still don't know how to write a ticket to the automated vehicle because who's the driver, which is what most of the state laws say. We're writing a ticket to the driver. I'll get back to that in another question I think that Josh will ask later. But from the perspective of an independent owner-operator of state infrastructure with law enforcement responsibility, there's some perspective on the components of traffic rules that need to be brought forward. First, for constitutional and historical reasons, traffic regulations governing the driver and the operation of the vehicles on the roadways are enacted and administered by the states rather than the federal government. So historically, the first traffic regulations were adopted by Connecticut in 1901. That was the first statewide set of traffic regulations. That's over 100 years ago. The first version of a uniform vehicle code in the United States appeared in 1926, and the first version of a manual and uniform traffic control devices was published in 1932. That's still almost 100 years ago. Given some perspective to this, it was 27 years later in 1959 that Hawaii became the 50th state. Okay. So for ADS developers, that means there are now 50 sets of state traffic regulation codes. Some developed before there was a uniform vehicle code template, most sporadically updated, and most containing provisions allowing local jurisdictions to create additional regulations within their boundaries. I think there's something like 2,000 sets of traffic control regulations that you might have to figure out if you want to drive through the United States. That's a lot. These traffic regulations often include clauses that indicate a regulation may apply when certain conditions are met or when posted, et cetera, et cetera. And that's where the MUTCD and its traffic control device standards, guidance, and option statements come into play. The 11th edition of the MUTCD was published in December 2023, and is, to the best of my knowledge, the first published American standard on preparing the infrastructure for automated driving systems. The 11th edition includes the new Part 5 titled Traffic Control Device Considerations for Automated Vehicles, and it includes supporting statements acknowledging the driving automation systems are a target road user. And I want to clarify that as a road user, not a vehicle, we're trying to manage the roadway environment for all road users, not just a vehicle or the vehicles. Because I think I heard earlier where someone was talking about managing the vehicles. Lots more out there than just vehicles. Historically speaking, the MUTCD rules and standards were developed on an average human driver, audio-visual capabilities and response times. These average human drivers, they can move their heads up and down, they can turn their heads side by side, they can look around the corner, so to speak. And as a rule of thumb, the expectation was the driver should be able to read text on a sign they are approaching at a distance of approximately 30 to 40 feet for every inch of height in the text. I don't know of an automated vehicle that can see 800 feet down the roadway and read the overhead guide signs yet. I'm not even sure there are a lot of them that are reading the standard regulatory signs that are within 200 feet of the vehicle. So maybe someone will make a disclaimer on that today. If today's ADS is able to perceive the roadway environment in the same way as a human driver, that hasn't necessarily been proven out yet. And in many ways, the answer appears to be no. So this is problematic when the regulations are variable by time, by condition, or as indicated on a traffic signal or dynamic message sign. Someone asked me recently to look into hand signals by emergency responders. And yes, there is a national standard of sorts, but states and local jurisdictions have written their own rules. So you could have someone trying to tell you to stop by putting their hand out and just facing their palm to you, or raising their hand higher up, or bringing it back. There's all kinds of different ways to signal that they want a vehicle to stop. Some people just point at the vehicle. So for ADAS to be a safe and cooperative road user in compliance with all traffic regulations, we will need to find the limits of the ADS perception and how it will affect their performance. I think then we'll be able to start working toward adapting the traffic regulations to support ADS within our road environment without disadvantaging the other road users. And last but not least, Joshie asked about stakeholders who have an interest, and I'm pretty much going to tell you everybody's interested. Whether it's the insurance companies that will have to pay out, whether it's the state and federal government having to discuss if the ADS is a driver that's regulated by the state or a part of the vehicle that is regulated by the federal government, whether it's the law enforcement and fire responders coming to the scene and trying to ensure they're going to be safe while arresting someone else. It's all going to be important because no great civilization has been built without a well-defined system of transportation that allows you and me to access those 5 necessary components of human life: food, water, etc. So Joshie, that's my whole spiel.
Yeah, thank you, Roxanne. Thanks so far for your last slides. I think this gives a very good segue for our next couple of conversations, because when I first read about these issues, I was just thinking ADS, right? And kind of machine understanding the whole, complex human language. That's a technical question. But then I realized, okay, even how law enforcement and judges will work together to give you a ticket. That's a totally different story. So yeah, I appreciate that multi-stakeholder view. We'll come back a little bit to talk about. But I would love to move to the part 1 of our webinar. That's kind of understanding the state of the art and how basically ADS are understanding traffic rules and regulation. What can they actually do now, particularly in the U.S., right? We have different rules from jurisdictions to jurisdictions. So is this maybe Kelly or Sagar? You work more with industry. Is this being hard-coded in these machines now, or is they actually are using some internal database, right? It might not be perfect, but how they're actually addressing this question now?
That's a great question. So let's consider the possible methods. One method is that you do everything just as humans do, driving in a completely novel new area that you say, I have no idea what the speed limit might be for this road. So I'm going to turn onto this road. If I don't see a speed limit sign immediately, I'm basically just going to follow along and go about the same speed as everyone else. And then once I see what the actual speed is, okay, maybe it says 30. Everyone else is going 40. What am I going to do as a human driver? Well, I don't want to be a traffic obstacle, so I'll probably maybe split the difference. What do you want an autonomous vehicle to do if there's ambiguity about what the new roadway is? So because of that case, because you don't always have consistent signage, maybe someone took out a sign, maybe someone vandalized it, you don't know what the lighting conditions are going to be, a very simple, reliable way to resolve what the speed limit, for instance, is to essentially have an onboard database that says, for each segment of your planned route, this is what the encoded speed is. That's very easy to check, it's verifiable, it's very straightforward, and it's very well managed. Because the speed limit laws, for instance, for governing certain segments of the road don't really change that often. And so we do have systems that can detect and read the road signs as well, so we can spot discrepancies, things like that. However, that is used as part of basically a signal saying, hey, we've got an error in our onboard system. And so we would primarily choose to rely on our onboard database for our planned routes. That's because it's independent of the lighting conditions or things like that, or any sorts of temporary ODD modifications that would impair our ability otherwise. So that's kind of the rationale of why it makes good sense as an ADS developer to rely on a very reliable system rather than waiting for infrastructure or other sorts of queues to develop a system.
But I want a follow-up question is, because the rules can be different, right? Depend, like as Siddhartha mentioned, it's the situation, or I forgot which word you actually use, but it's really or ODD, right? It's the sensors, right? The vehicles to be able to sense what's surrounding, what's happening out there. But then the rules in the US is different from here to here. But how they address that differences in the rules now? Do they even address it, or they just code? For example, they're doing multi-state driving. On the one freeway, the left lane use might differ from one state to the other. And how they understand the left lane use difference?
Oh, well, so yeah, for how we solve this problem is as a function of the route, there are preferences of which lanes are preferred or not. And so that can be encoded as a preference of saying, when possible, for instance, it's generally culturally acceptable within our ODDs to keep trucks in the rightmost lane. Now, different states and different jurisdictions have some laws and some not that say what the utilization is of a left lane for passing, and maybe trucks are prohibited in certain jurisdictions. For instance, certain states have different speed restrictions for autonomous trucks or trucks in general, depending on what it is. So maybe the prevailing traffic can operate at one speed, but trucks must operate at a different speed, for instance. And so we just have that encoded into the map. And that's something that is directly verifiable as opposed to trying to teach by example or something like that. So this is kind of part of our approach of what we call verifiable AI in our driver, of when it's possible to use directly introspectable, explainable decision-making, we absolutely want to use that. And we try to shy away from things that generally require more ad hoc reasoning and decision-making on the fly, because that is less verifiable. And so we want to err on the side of things that are more explainable and defensible and knowable ahead of time.
Yeah, thank you. So my understanding, that still look like it's coded in your system, right? But then Sagar, please go ahead.
Yeah, so a few comments on this, right? If you look at it from first principles, there's like 4 broad categories of how you could tackle this problem. And the problem, to be specific, is that you're operating across regions which have different road routes. So the first thing you could do is that you could try to form a parallel effort to harmonize those road routes. And then if and when they're harmonized, you follow the harmonized set of road routes. This is one approach. And these are not all mutually exclusive approaches. The second thing you can do is, basically know where you are and switch between different rule sets based on where you are. And this is something that one can do, assuming that you can codify rule sets of each region, and then you switch between them. And I suspect, and I know that a bunch of companies are taking this approach. The third approach you can take is, instead of switching rule sets depending on where you are, you maintain awareness of the rules. Let's say you're driving across 3 different regions. You maintain awareness of those rules, and you pick the most conservative behavior that wouldn't get you ticketed in any of those 3, and assume that, not assume, but verify that picking the most conservative behavior doesn't actually create secondary problems in each one of those jurisdictions. And the fourth one, which is sort of the most nebulous one, but there's still some companies doing it, is you generally do what you think is the right thing to be safe and hope you don't get ticketed, which is what humans do. So let me give you a precise example, right? There's 3 different jurisdictions. In one jurisdiction, if you are coming up to a pedestrian crossing, the rules say, if you think that a pedestrian is about to cross, you must yield to them, right? This is the rule. It's not the exact rule, but this is what it means. And it already presents a lot of problems with, what do you mean you thought he was about to step into the crosswalk? Huh? So that's the first one. So you're supposed to yield if a pedestrian is about to enter the crosswalk. In the second jurisdiction, the rule is, you can't, like, assuming you've stopped for a pedestrian, you can't start moving while the pedestrian is in your lane of travel. If the pedestrian is outside the lane of travel, you can start moving. And the third jurisdiction is, you can't move unless the pedestrian has exited the crosswalk. Forget if they're already outside your lane of travel, they need to have exited the crosswalk. That's what the letter of the rule says. So now if you are an AV or an AV developer operating across these 3 jurisdictions, what can you do? You can, of course, know the exact rules and you can apply them based on where you are. What do you think humans do? Do humans actually know, oh, I have just crossed the state line here, I should not move when the pedestrian exits my lane of travel, I should move when the pedestrian leaves the whole crosswalk? I don't think humans do that. They sort of do the right things, and they also trust that as long as they were adequately safe, no law enforcement officer is going to come and say, the pedestrian was 1 meter away from the curb. Never mind, he was 10 meters away from your lane of travel. You moved, so ticket for you. That generally doesn't happen. And so as an AD developer, what are you going to do here? You can codify the rules and switch between them. You can generally do the right thing. You can argue for rules to be harmonized. Those are basically the options on the table.
Yeah, one thing I'm sorry, Shaki, is
Go ahead, please.
So Kodiak focuses on doing over-the-road trucking, but we've also started doing development in industrial applications on essentially dirt private roads. And what's really interesting about this is that these are undivided roads, so traffic coming both directions. There are no lane markings. There's no clear edge to the road, and human drivers often break the speed limits. And and because of the road condition, there might be large potholes or things like that. So an oncoming vehicle may cross into our side of the road and come right at us before coming back over. Another thing is, pedestrians in this environment are generally pretty wary of trucks, rightfully so. However, what should our conservative driving policy be? There's no regulations on how we're supposed to handle on these private roads and unmarked environments, how to actually resolve this. So it's actually a great test for us to essentially, how well does our over-the-road trucking system generalize to an unstructured environment where there is no clear right or wrong. It's instead more of a question of risk and justification of, like, was that a reasonable, predictable behavior? And so it's kind of the opposite end of the extreme, rather than being so fixated on demonstrating legal conformance to rules that do exist. Instead, it's how well do you exhibit good driving behavior and good common sense and courtesy to all the other road users, particularly when there's no strict expectations. A lot of uncontrolled intersections, And in particular, what do you do in Sagar's instance if someone jumps into the road or jumps into the crosswalk and then jumps back out and jumps back in and kind of does the hokey pokey, so to speak, and challenges your system to see, hey, this is really confusing. What am I supposed to do here? Those are like the types of cases that often are actually the really tricky ones of when someone is being unreasonable, and how does the system respond, making sure that it's still courteous and safe and things like that.
Yeah, thank you for the comment. I think I want to kind of piggyback to Sagar's comment on the 4 different basically approaches you can move forward. And I think this is a time that I want to mention that at least as far as I know, there are at least 3 groups, right? 3 groups or 4 groups even in the US working toward different directions. I can quickly mention them. I think Federal Highway Administration had a project. That project is basically trying to looking at this multi-stakeholder, how multi-stakeholder can work together. The project team, I think, struggled a little bit as well, just trying to figure out how these different schools can really work together, what are kind of the organization structure, and who will take the lead to develop this kind of standardized, harmonized rules or specifications and so on. I know that there's another industry or industry group organized by a company called MITRE. This is still in the initial stage, but they're trying to develop some harmonized standards as well. And then I know there's another international ISO effort called METR, METR. They are also went a little step further, trying to codifying the whole traffic rules of human traffic rules. They call meter rules, and then using that and storing a database. This sounds like everyone is going toward a lot of interest in going toward that harmonize the rules and codify these rules. Partially from my perspective as an engineer, it's something tangible, right? We can see something, I can do something on top of it. But my trouble is that it can't solve all the problem. If I have difficulty, understanding how we can solve the rest of 20 if we keep going that approach. And this is also related to there's an ambiguity to it. We're talking about it, right? How we can solve that, right? 80%, we don't care about 20% anymore, just care about those harmonious rules. Anyone want to comment?
I might go for that one and slightly qualify some of the comments I made earlier. Also, I think let's not kid ourselves by saying that there was going to be a deployment that would be all over the country all the time, and the same stack is going to do that. I don't think there is anybody who's mature enough to do that, and in the time to come, I don't see that happening. There would be definitely cross-state applications, and Kelly and Kodiak is a very good example of that. But then when you do cross-state, you're also all fixed routes. And as a result, you're constraining the problem. So I think whenever we try to talk about challenges and problems, we tend to see the whole ocean rather than actually saying, how are we constraining the problem to make it manageable? And I think as engineers, we'd like to find solutions. And one way of finding solutions is to constrain the problem that you're trying to find a solution to. So fixed routes interstate is one way, or the other way, like in terms of some of the urban deployments, is you only do it in a particular area. And in that particular area, the rules of the road remain the same. They don't change, but they might change as Roxanne has kindly put in, that you might have dynamic signing. And as a result of that, you might change some of the hard-coded rules might need to be reevaluated in real time if there is variable message sign, so on and so forth. But I think the problem that we're trying to solve is not as big as we tend to think if we want to try to boil the whole ocean. A city deployment in a particular city, and in all honesty, there's only a few developers who've actually done commercial city deployments, and the way they've done it is city by city. Nobody is saying, let's go all over the US and deploy all the cars at the time and let's make it happen. That's not happening, and that will not happen for a number of reasons. Rules of the road is only one of them. So let's see what's the practical way of doing this. So the practical way of doing is either city by city, which means the rules of that city is already defined, so that manages your problem in that sense. If it's interstate, it will all generally be fixed routes on on freeways in your case, and that's again you manage constraining the problem itself. The problem that I think we need to also subdivide the actual problem is there's a bit around the formatting of the rules, especially when you have multiple stakeholders. So when you have multiple stakeholders from legal enforcement, local authorities, state authorities, federal authorities, each of them need to be talking about the rule in the same way or the same format. There is no harmonization around the format. That's one aspect of the challenge. And the other aspect is this content as to what is going into the rule itself, the numbers, the ambiguation, so on and so forth. To Sagar's point of jumping on the crosswalk, if you look at the UK rule for that particular situation, the way it is written is, if the pedestrian is in the crosswalk, you're supposed to yield. And if human drivers follow that rule, we will never stop at a crosswalk, because a pedestrian will not actually be in the crosswalk if they are actually seeing the vehicle coming. So the way they have been written is actually different to how we as humans actually realize them also. So I would say, rather than saying there's a big problem, I would say, what is the actual problem for the use cases we have? And what is it that we need to do for that use case? Yeah, to be realistic, AVs are not going to be there everywhere, every city, all the time. That's not happening in the near term. So let's just look at what is the problem that we have in hand. I'll stop there.
Okay. Other panelists, do you want to?
Yeah, I think to build on Siddhartha's point, there's the idea of like malicious compliance. How bad would it be like when my children do exactly what I tell them, exactly instead of what I want them to do, they do exactly what I ask them to do, which is sometimes problematic. And sometimes our traffic laws can be subject to the same sorts of issues. So I think that the traffic or the crosswalk is a good example. And so if there was a easy, direct mathematical specification that you could give of the desired optimal driving behavior, people would have done it already. And so if that was a direct verifiable specification, we wouldn't ever have to essentially like really work too hard on this problem, because we could just like build that formalism. The issue is there's too much ambiguity, and essentially the permutations are too vast. And so if you think about how do we assess new human drivers, we give them a quiz of their knowledge of road rules. And then we ask for practical demonstrations of saying, I'm going to give you this situation. I'm going to evaluate your ability to safely handle this situation to demonstrate conformance to the road rule. However, as we're driving in our day-to-day driving, most humans actually, violate a rule here and there, go a little bit too fast and stuff like that. A good example of this that we have in trucking is, believe it or not, people will cut off big, heavy Class 8 trucks all the time and put themselves into very unsafe, or make our truck suddenly in an unsafe following distance to this vehicle in front. So our truck didn't do anything wrong. Someone cuts us off. If we want to maintain a reasonable following distance that is safe, how should our truck respond? Should it slam on the brakes aggressively to recover that following distance, potentially jeopardizing the safety of someone who's following? Now, legally, it is their responsibility for a following vehicle to not rear end us. So are we justified in that action? Or what is the urgency that we should use to recover that reasonable following distance to be conformant to the rules of the road? And so there's considerations here of like, what does that person owe us after essentially denying our right for a reasonable following distance? And then what are we able to impose on others? That's a very complicated question. It's actually, I think, imbued with culture, of what are your cultural values? And that can vary based on jurisdiction and ODD and area. But I think we should be very mindful that sometimes the rules that are codified are not the right actual behaviors, and that what we actually want is different than what we wrote down in the law.
So I want to comment on that very last statement, because I find it fascinating that the rules are sometimes not the rules. So the diversity of rules and the lack of harmony is sort of one issue, but there is this adjacent issue, which is when we say AV should follow the rules, implicit in there is how strictly should they follow them. And if you look at the spectrum, one end of the spectrum is the rules are the rules. They should never be violated. And I think we can all agree that we're not really living in that world. The other end of the spectrum, the other reasonable end of the spectrum is all rules really are guidelines. You choose whether to follow them or not. And I don't think we are fully at that end of the spectrum either, right? Like people don't choose to decide whether to stop at a stoplight or not based on if they can see other traffic coming into the intersection. Sometimes they do, but usually they don't. And we can, I think, all agree that it's not recommended to do that. And then there is a certain category of these rules are guidelines or not. It really depends. And depends on what? It depends on the situation. Well, what do you exactly mean? That's where all the codification part starts breaking down. And so we can talk a lot about whether vehicles should follow the rules of the road, but we need to also complement it by saying, what does adhering to the rules mean? Is it a black and white thing, or is it treating them as guidelines to do the right thing?
Yeah, thank you for the comment. And just follow your black and white comment. I think one issue we haven't really talked about, I think Sigal, you mentioned in the beginning, is the ambiguity in that traffic laws. A lot of things like keep safe distance, or there's a lot of things like that, ask using human judgment, right, to follow traffic rules. And I think this also related to one of the questions in the chat box now, basically asking how states authorize law enforcement to cite ADS vehicle that violates rules on the road. And this question talks about even ownership of the vehicle and who is liable. I think I'll go to that later. But I have a question about this vagueness. How are we going to address this vagueness, right? How, you mentioned codify it, and then we recommend values for different situations. And then who's going to stand behind that values, right? For example, a bunch of industry group, they agree that this is a good value. This might be a research value. Technically, it's a good. However, I just had a hard time to think through the process. Who's going to use that value in the law enforcement process? Like I'm an ADS vehicle. I followed a very safe behavior, which is the industry agreed good practice, right? Best practice, and then still cause some dangerous condition, and then the police officers may pull it over, and then judges will make the judgment eventually. But I feel like either DMV or regulators or the law enforcement, they're not gonna say that, okay, because it's a research value, right? It looks okay, then you're fine. And nobody will say that. So I'm just having a hard time with the vagueness, and then this codify approach, what role it plays, and how it plays in the overall particular law enforcement process.
But Joshie, you're in an at-fault state, aren't you? And some of us live in a no-fault state. But basically, if it says when safe to do so, and you get involved in a crash, it wasn't safe to do so. And so translation is, don't get involved in a crash. But how the ADS is going to do that will be very, very interesting with all of the conditionals. Even if the ADS is fully programmed with 100% of the traffic regulations that apply, the minute we have a flood, a hurricane, a fire, the rules can change, and they're all temporarily controlled. And as we're starting to see, the ADS does not respond appropriately in all cases to emergencies. And so how are we going to start addressing that? But really, your question is, what are those conditional statements doing? And it's a judgment, right? How do I ensure that I don't impinge on someone else and make it unsafe for that other road user? And how do I keep myself safe at the same time? And I'll leave it up to the ADS developers to tell us how they do that.
So I want to give an example. I'm a huge fan of examples. So here's an example of why this is so complicated. Let's say you're making a right-hand turn at an intersection, and there could be somebody coming from the left side and potentially hitting you, but you can't see them because that view is obscured for some reason. So you're making a right-hand turn. You have to be cautious that somebody could come from the left-hand side and hit you. Okay, that's the situation. Let's say that the prevailing speed limit is 35 miles per hour. Now, when you are about to make that right-hand turn and you know somebody can come out of the blind spot and potentially hit you, what speed should you assume they're coming to hit you? The speed limit is 35 miles per hour. Should you assume that if anybody's coming at 35 miles per hour, they won't hit you? You could do that. And then if somebody was speeding, they would come and hit you. And as you said, Roxanne, there was a crash. So by definition, you are not safe. Now, most developers who enter this situation, they won't assume that nobody will come at you at exactly the speed limit. So should you assume that, okay, if the prevailing speed limit is 35 miles per hour, people could come at you at 40 miles per hour? Sure, that sounds reasonable. Do you think people could come at you at 45 miles per hour? Maybe. Do you think people could come at you at 100 miles per hour? Probably not. Sometimes they might. Okay, so there's no black and white. We are playing a game of probabilities here. When I'm making a blind turn, at what percentage above the legal speed limit should I assume somebody can appear and hit me? If I assume somebody's going to come out at 100 miles per hour when the speed limit is 35, I'm going to drive in a way that's so unnatural. Okay, but if I assume nobody will come at 35 miles per hour, that's a problem too. So what do I do? Technically, what can I do? Here's what I can do. I can observe traffic and I can build a distribution. Oh, X% of the time, people speed no more than Y% above the speed limit. So I can build that distribution and I can put my finger somewhere, 90%. Okay, I am going to drive in a way that I'll be safe in 90% of the cases or 95% of the cases. So let's say I do that. I say I'll be safe in 95% of the cases. And then I encounter something in the other 5% the next day and get into a crash. Okay, I can come as an engineer with all my data. I can say, this is the analysis I did. I analyzed that the speed limit was 35. 90% of the time, nobody comes at me at more than 50 miles per hour. So I was safe until 50. This guy came to me at 60 miles per hour. So that's my reasoning. Now, who is to say that, okay, developer, you picked the 95% value to be safe. You should have picked 97. Okay, there's no guidelines. Now, if there was an industry standard or a regulation that says, assume people can speed 10% above the speed limit, no more. Beyond that, you're off the hook. Great. Now, as an engineer, I know exactly what to do. But is such a regulation coming? No. Okay, so in order to be safe, as an ADS developer, I have to make assumptions. Those assumptions can be data driven, but at the end of the day, I'm going to put a finger on the chart and say, that's where I choose to be. So we have to make assumptions. And when those assumptions get violated, what sort of air cover do we have? This is an open question. There's no government saying make this assumption or make that assumption. There's no industry standard saying that. Each ADS developer has to make a choice. How do you make that choice?
That's a great.
Okay, I'll stop there.
I love that, Zaire. That's something I deal with all the time. Looking at intersections of saying, I know that the speed limit is X and vehicles sometimes, rarely, go 2X the speed limit. And so, oh, well, that's really not good. So do I need to essentially go beyond what industry can offer in terms of perception systems, in terms of what the sensors are capable of perceiving, to try to make sure I don't put at risk someone who's so wantonly violating the rules of the road? What are they owed? And what is our truck owed in terms of, I have an expectation that someone's not coming at 200 miles an hour behind me. So when I pull out and do a lane change, if I don't see them as a human, or if I check my blind spot and I say, I don't see anyone, and I pull out in front of them, was that unreasonable if someone else is acting, so wantonly, egregiously, unsafely? And so I think that is like a key thing that is unclear of how it will be resolved in the court system, because these AVs will have recordings of the whole scene. of what exactly happened. And then how is that going to be used as evidence? That's going to be very different. I think than how we do things today. You know, some folks will drive with dash cams or things like that, and some vehicles have onboard camera systems equipped that could supplement that. But we are getting direct measurements of speed, accelerate, you know, and we can estimate acceleration and things like that. It's a different world of how you would resolve culpability or who's at fault in a way that was not previously possible before. But again, it kind of creates almost like a privileged class that the AVs would be able to uniquely defend themselves, whereas human-driven vehicles that are not equipped with this sensing technology would not be able to use those same arguments.
So here's a thought experiment that is a bit dystopian, right? And I think it goes to the heart of this issue as well. I like to say that we give humans grace for being human, and we don't extend that grace to machines. But let's take this example that we are discussing. You know, to what extent can you assume somebody will violate the speed limit when they come at you? This problem is also true for human-driven vehicles. So what assumptions do human makes? What assumption would you make when you are driving and making a right turn? Maybe you aren't even making an assumption, right? Your subconscious is doing something. And let's say you get into an incident. This case goes to court. At least in the US, a jury of 12 people will decide, taking into consideration various factors and precedent, whether you are guilty or not. Now, here's the dystopian part. I could probably make a machine learning model and have it study case law for the past 100 years. Study every traffic incident court case in the past 100 years. And this little bit of machine learning code in real time could tell me, if you are about to make this right turn, will a jury of your peers hold you guilty? Yes, no. Or to what probability? But is that really how we want to do it? Do we want to drive based on whether the court system will find us guilty or not? Like, to some extent, that's what humans do today. But I would argue that's not really a great way to design the next generation of autonomous driving systems. Will you be found guilty or not? In other words, to what extent will you be held responsible for this? By the way, if
I just wanted to
listening,
add
this is
a
a
point.
great idea for a startup. Build a machine learning model that analyzes previous court cases and tells you if a certain behavior is likely to get you into trouble. I'll stop there.
I just wanted to add one point, but before I do that, I think if anybody wants startup ideas, please listen to Sagar's talks. Every talk he does, there is a startup idea that is there in that talk. But anyways, just to bring it back to Jashi, your point around the Amica, I think Kelly and Sagar have raised a very interesting point, and I think we are asking the wrong question. I really don't think we need to ask the question, do we need an industry standard for the ambiguous terms in terms of what it should be? Every developer, and we've got just two examples here, will take an approach to actually come up with what that number looks like. Somebody might say 95%, 97%, some might say 1.7x and all that stuff. I don't think we need to focus on what is the right number. Essentially, it would end up being, can the developer explain why they did what they did? And I think that's the approach that we have taken, at least in our conversations at the regulatory level, in the type approval world, that the developer will need to explain the approach they have taken. And I would think it would be unrealistic to expect the industry to agree on a number, because that number has so many factors that impact it. It's such a multi-dimensional construct. So I don't think we should focus on that. What we should focus in is the approach. We could say different approaches to actually coming up with the numbers are X, Y, and Z approaches. So Sagar mentioned one, Kelly mentioned one, every developer might mention another one. So I think if you look at even at the IEEE 2846, they wanted to come up with numbers and it became a guideline document. So I think there's enough precedence in this space to say trying to standardize numbers is kind of foolish in this particular space.
Yeah, and one thing we do, once we pick a line in the sand, we say that's what our system's going to do, that's the limit, because you have to pick a system, or you have to pick a limit so you can verify against it. What you would need to do is that a good limit? what is the risk, kind of to what Sagar was talking about, what's your exposure to, for instance, at the intersection example, someone traveling more than 50 miles an hour in a 30-mile-an-hour zone for that particular intersection. You could say, well, let's go do some data collection. Maybe you sit there with someone with a clipboard who's watching that intersection, or set up some cameras. You say, over 3 months of data and 10,000 vehicles passing through this intersection, I never once saw someone approach at 50 miles an hour. I saw people running it at maybe low speeds, but never once at 50 miles an hour. So what's the risk? Well, we model that in probabilistic risk assessment of saying, I know it's technically possible, and I need to come up with some sort of prior of how likely it is, even though I know it's probably less common than 1 every 10,000 vehicles, but I know it's still technically possible. And so therefore, if someone were to come through that intersection at 50 miles an hour, or 55, let's say, let's run a simulation, because we can't actually do this in the real world. Let's run a simulation and see what our system would do. How well would we detect that vehicle? How would we react? And then it would say, well, if there's a collision, how severe is it? And then you essentially rack and stack all those scenarios of essentially how well does your system cooperate with unreasonable actors, and then you put it into your bucket of risk and you say, this is what I think that the risk is of my driving policies operating in this particular ODD. And that's what Kodiak does with probabilistic risk assessment, is we have to pick thresholds and then we have to justify them, and the way we justify them is based on what is the expected number of collisions that we will have per mile on average.
Yeah,
And
thank
from, sorry,
Oh,
Joshie, but
go
from a
ahead.
development standpoint, is it just Kodiak's perception, or do you talk to your insurer and say, how much risk can we accept before you're going to take us off the road?
Before they, I'm sorry to understand the second part of the
So
question.
you're establishing an amount of risk that you're willing to take for different types of behavior, whether someone's approaching too quickly and you're not going to be able to avoid the incident. Isn't part of that decision making talking with your insurers, not just waiting for a judicial decision if you actually get in a crash, but talking to your insurers about how much risk they're willing to have you carry?
See, it's not a discussion we've had, right? In the same way that your maybe your personal auto insurance may not ask you questions about what's your policy as it relates to intersections or things like that. It's more handled in the traditional freight insurance, or like trucking insurance stuff. So that's not a conversation that's, or at least I'll say this, I'm not aware of a conversation. Maybe it's happened independently. But I think it's an interesting point. How would the insurance company know what is a safe behavior? If the insurance companies know what the safe driving response is at intersections or for lane changes or things like that, and if they can tell me what the threshold is, I will absolutely go talk with an insurance company, get that answer from them, say, tell me what you are willing to underwrite if I have that as the policy. And so if they have the source of truth, I want to hear it. But my suspicion is that they may actually not have that information, that they will just have trends, actuarial trends of people who have gotten involved in accidents. It's typically in these sorts of conditions, but they may not have a good defensible threshold that they can provide you.
So yeah, I thank you. Great points. I just want to check the time a little bit. So we have actually 10 minutes left. How time flies, right? I probably only go through half my questions so far. But with 10 minutes left, I've been monitoring our chat box. I think a lot of you are doing question and answer box. I will try to ask them to any. I'm trying to see. We have addressed actually the almost first 3 of them already. If you have any questions, please type in. I have 2 more questions I want to ask our panelists, and I will ask that questions very quickly. Unfortunately, our staff tell me that the audience cannot unmute themselves, so please use in the chat box or the Q&A function to ask questions, and I will read that. I will piggyback to Roxanne's question a little bit about insurance. This is one of the important stakeholders. I'm glad that you mentioned. I was about to bring some other stakeholders we got talk to, and then judicial systems. We were involved in some of the engagement with the judges. Basically, they have troubles. They're thinking case law approach might be becomes difficult because it's too much. Right, and then by your startup concepts, Car can help them solve the problem using machine learning. But anyway, so Roxanne, from your perspective, infrastructure owner's perspective, and you work on the traffic control devices, what are the places where you see that ADS vehicles are constantly, not being able to follow the rules, and that's something that infrastructure can support?
So even if you just start looking at the ADAS systems that are currently on the market, there are some interesting conundrums. The sensor suites are set in certain positions. So when you're approaching a curve, for example, it's very slow when it starts to turn, and it starts turning at a harder rate than a human driver would be. You can feel a little bit of discomfort in a lot of the cars that are out there now for the passengers. I think a lot of that is where the infrastructure side is concerned. What do we have to adapt so that the ADAS system or ADS system can perform adequately? How do we make sure they have enough sight distance to react to the condition? But it's going to be a give and take. I think once the cars get on the road and they start crashing, this is really bad to say, I'm sorry, but once they start crashing, we'll know what needs fixing. In the meantime, there are things that are really bad in the deployments that happen because people accidentally turn something off or turn something on that shouldn't be there. And so we've had vehicles that assumed that safe stopping location was the middle of the crosswalk because it had a handicap ramp available for their passengers. Kind of against the law, but that's what they assumed. Or, you know, they drove at the pedestrian because that sensor suite was turned off. So I'm not really sure how to answer your question, Joshi, except for to say we've found things besides of not being able to see around curves, not being able to see LEDs properly, not being able to read the text on the signs. Those are all part of the traffic regulatory system, and over time, we're going to have to figure out how to overcome it.
A lot of the dynamic traffic control are through LEDs. So if they can't read LEDs properly, that's going to be a big problem.
An example we weren't expecting is even the LEDs on the cars can be a problem, because if they look like they're flickering, that creates the appearance that that car is an emergency vehicle. And yeah, lots of issues.
Great. Thank you, Roxanne. I want to go to one of the remaining questions, which is posed by Bradley Traps. I think we kind of addressed a little bit how states and authorized law enforcement to cite ADS vehicle that violates the rules of the road. And then Brad mentioned in practice, it's difficult because depending on the state law, the responsible party of the ADS operation is the vehicle owner or the operating company, and so on, right? Both present challenges for issuing citations and so on. So do any of the panelists want to kind of comment on this a little bit?
So if you look at what we're doing with NHTSA's investigations into Tesla, they're considering those performance issues a car issue, not necessarily a driver. But technically speaking, with the level 3 vehicles, the driver is supposed to maintain awareness and take control. Once we get to level 4 vehicles being on the road, that's going to be a completely different discussion.
Yeah, and also I guess Brad also commented that eventually civil and criminal case laws will say that is it acceptable, isn't acceptable. This kind of go back to, I think, Siddhartha, your comments, right? We are asking the wrong question. We should not trying to set a standards for the vagueness or set those values, but instead we should be able to explain them. I was about to ask that question, kind of similar to this question as well. Do you mean that you will leave it to the judiciary system to interpret the law, leave to that system to make the final decision, right? The industry, it sounds like in your approach, it's like only making a best practice, right? Guidelines instead of going to like the regulation level.
Partially, I would say yes, but the industry, each developer are still looking at how they're coming up with the numbers. So is it data driven, as we've discussed today? Is it based on this new startup who will create this machine learning model that would go through case law, and so on and so forth? So there has to be a way of coming up these numbers, and that way should be enough that the industry can confidently say that we know our system is safe because we have followed this process. It's traditional safety management systems itself. It's kind of a part of your safety case argument. One thing I know, the lawyers are going to get very, very rich as a result of this process, because they would be in a lot of demand, because everybody would like to get hold of somebody to defend them at the court. Ultimately, it will be in a court decision, even because I don't think that's an issue, because even for human drivers, it is a court decision. So when you get a citation in your case, or we get a ticket, as we call it in the UK, it goes to a court if you want to fight it. So I don't think why we should be worried about that. What we need to do as industry is make sure that we have done the best we can, and be diligent enough. And you could actually write guidelines on what diligence means, what best means, but you cannot actually say it should be 3 seconds or 10 seconds.
Great, great. Thanks so much. Now we are 2 minutes in toward the end of the seminar. I'm sorry, we have still a lot of questions I want to ask, but that's what it is. So now I would like to invite each of the panelists. Can you just leave an ending comments and basically provide a quick summary and also give us some insights on how we should move this forward? Sagar, do you want to start?
Well, I definitely think that more such discussions are definitely needed. I've been participating in rules of the road conversations for a while, but every new conversation brings up quite a few insightful comments. So I think we are still at a stage where I personally believe we are still getting more and more inputs before we actually start converging, even though some convergence activities have already started. So I think more of this is needed. I'm also, I've learned to be cautious that anytime I get excited about one particular solution and think this is the way, another part of my brain says, the moment you think one direction will solve your problem, you're probably going to be wrong. It's going to be a combination of a few things. So I like very much the work that Siddharth is doing on codification of rules, Siddharth and gang, but since Siddharth is here, and I think it will take us very far. And the third topic that I feel we must address pretty squarely, and I think Jane Lapin mentioned it in her question, is we didn't get the chance to discuss this, which is what do you do when adherence to rules of the road increases the risk in a given situation? I feel like as an engineer or as somebody who might be in a vehicle in that moment, I feel I know what the answer is, but as society, do we agree on what the answers to that questions are is super important. Thanks.
Great, thank you. Siddhartha, do you want to go ahead?
Yeah, I'll start by saying I thank you for doing this. I would love to be in a panel with Sagar. I'm keeping a note so that one day I come up with a startup, I will know which ideas to use from. But as I think my parting comment would be to ask the right question in this space. So let's not try and boil the ocean. For your use case, what is the right question? So if it's an interstate use case, what is the right question for the interstate use case? If it's a robotaxi urban use case, what is the right question for the rules of the road for that use case? So let's not try and boil the ocean in this space. And lastly, I think we would be kidding ourselves if we say we'll come up with an industry standard number. I think we need to move away from that conversation and talk about at least we can get the industry to speak the same language in terms of how you write a rule itself. I think that would be where I would stop today.
Great, thank you. Roxanne, you want to go ahead?
I would say that technology might solve some things, but it's not going to solve everything. And so for everyone working in the space, we're going to have to be adaptive and cooperative and try to avoid that one solution fits all, because that everything looks like a nail when you've got a hammer problem, makes everything a screw instead of a nail. Thank you.
Thank you. Last but not least, Kelly.
Today, our systems, we have a lot of ability to do introspection on our systems, so we can understand why our system chose to do X or Y. But you can imagine sometime not too far in the distant future where our systems are so sophisticated that it may be difficult to understand why they made that choice, and yet they drive very well. And this is actually exactly what we do with people. Our brains are too complicated to directly introspect why they did that particular choice. And yet we grant the right to operate on our roads using a very sparse test set to other humans. And we say, yeah, that looks about right. And then when they go out and operate, they bear the liability and the responsibility of harm, right? If they do something wrong, they can be penalized for it. And so I think maybe the existing approach that we have today is actually, maybe that's already good enough to extend into the future.
I like that. Don't bother even doing anything. Cool. Thanks so much.
That's not quite what I said, but
Sorry, I'm just. I got your point. I think that great. Especially, I had a question I didn't get a chance to ask about AI with this new models coming. Their comprehension capability get much better. There might be a lot of opportunities there too. And this autonomous driving technology might be totally different, like in 5 years, because of transformation of AI. All right, that's all. We're actually 3 minutes past already. Thanks so much for the panelists for your time. 1.5 hours of discussion. You probably need to get some water, and also appreciate all the audience to stay until the end. So we will post the recordings of this webinar on the Mobility COE website, and we will also share future event information on our website and LinkedIn page too. Thanks so much for your attention. We'll see you soon.